Hi there, so this is going to be a short tutorial on how to operate the control box that drives the turntable and also on how to debug the connections in the case where there's loose wiring. I don't expect that to be very often, but just in case you have to do things by yourself. So what I have over here on the left is a breadboard schematic that shows the connections, so you can be able to relate what component connects to which, because on the actual hardware itself the connection kind of seems pretty funky. But I also have included the pictures over here so you can be able to relate the actual hardware with the connections. Also on the second page I have on this document, there's also a list of instructions that shows which components connect to what numbers of the connections on the microprocessor and what connections also on the stepper module. So these are detailed instructions which are pretty straightforward and it's pretty easy to follow. Okay, so let's go through over the components. So first I have the microprocessor that's basically giving the instructions for how to turn the turntable over here. And I have the push buttons that goes clockwise and anti-clockwise, so you'll be the one pressing onto these buttons. And what I have over here is the stepper motor driver, which is characterized by this white rectangle box over here. So the microprocessor is going to be feeding instructions to this control box, and this control box is going to be flowing out. The signal of the control box is going to be flowing out into these four wires over here, into the motor over here. So you see A plus, A minus, B plus, and B minus can be flowing into the motor, and the motor in real life looks like this. So okay, I also have a DIP switch over here, which you can see on the left side of my breadboard. So basically, these switches are to actually control the power output of the motor. So let's say if you have something that is 0.5 kilograms, so 500 grams, and you want to turn it 5 degrees, you want to hit one of the switches, right? So if you have something that is maybe 3.5 kilograms or 2 kilograms, you want to hit one of the other switches and turn the other one off. So these are basically different modes for different power outputs, right? Because it requires more torque if there's a heavier load, and you don't want it to be turning too much if you're putting out too much power for like a lighter load. So make sure that if you're turning on one of these modes, you turn off the other switches inside this DIP switch. So if you're going to mode 1, you're going to switch off the other modes, right? And you're going to turn on like mode 2, then you switch off the other things. So if you're turning it on, you're going to hit it up, right? You're going to flip it up. If you're going to turn it off, you flip it down. Okay, so yeah, I kind of want to go more in depth into the connections so you can kind of really understand what's happening here. So if you see the push buttons over here, it's kind of connected by two parallel connections. So one is the resistor over here connected to the ground, the blue bar over here. So it can be anywhere in this blue bar here. And the yellow wire over here is connected to the red bar over here. And these kind of align with the button, and the button's connection, if you see, is linked up to the orange wire, goes through the gray wire, and then goes into the orange wire back into the connections over here. I'm just going to scroll in a bit here. So it goes all the way to D5, right? And same thing for the other push button as well. It goes to D6. You can also scroll over here to see what's happening. So yeah, you see this is you see over here, this goes to D6 here, right? And then this goes for D5, right? Right, if you see these two pins over here, the power is connected to V in. This red wire is connected to V in, and the black wire is connected to ground, so GND. You can see at the two ends over here. So these two are the plugs that will be going into the 9-volt battery. You also notice that over here, I believe the 5-volt, right? You can't really see the wire over here. There's a 5-volt wire connected over here to the red bar over here. And there's also, from the same column, there's also a black wire, a ground, coming out into this blue bar. And this connection is also going to be connected by the white wires over here. So this bar and this bar, they're linked up together. So as you can see, that power, the ground, the blue bar, is kind of hooked up to the other side of the blue bar over here as well. You can see that the blue is connected to blue, and the power is connected to the power too. For the LEDs, you can see over here that the short end, the ground, is connected to the blue end, and it's coming out, which is going to be adjacent to the resistor over here. You can see these two resistors are the same, and this is going to feed into the green wire. I'm kind of in the schematic over here, the green wire is kind of going over, right? The green wire, and it's going to go into the connections, which are, I believe it's D2 and D3. So you can see that this goes to I believe D3. This one goes to D3, and this one here goes to D2. So the connections for these two are identically similar. Also on the left side over here, you can see that the top side of the DIP switch is connected. All of these, each of the connections are connected to the blue end. So the top part, the on part, is connected to the blue bar on top. You can't really see it on the actual hardware over here, but it's kind of behind this wire, right? So this is connected all to the blue bar, and you can see that the other end is connected to the inputs of the microprocessor from A0 all the way to A3. Okay, so we also have another 3 connections from D10 to D12. You can see the 3 ends over here, D10 to D12. They're connected to the, I believe, the positive pins on the stepper driver. So if you look over here, D12 is connected to pulse, or the pulse plus, right? And then, or the step plus. And then D11 is connected to direction plus, and the enable pin, which kind of enables power, is connected to D10 plus. As you can see over here, the connections that goes from the minus pole pulse to the minus direction, and is looped into the enable pin. And coming out from the enable pin, there is a black wire that is kind of looped over and grounded. You can see over here. So this loops all the way out, and it goes into the blue bar over here, or it also can go to the blue bar here since they share the same thing. You can see the connection is evident over here. You can see that this kind of flows out, right? And this flows into the blue bar here. Alright, so we also have the power adapter, the power jack adapter. We have the ground, which is the black wire connected to ground on the stepper module, and we also have the orange wire that is connected to VCC on the below of the stepper module. You can see over here, VCC. We also have the these connections, right, that I've mentioned early, from direction plus, pulse plus, and also enable plus that connects to the microprocessor. And also we have a bunch of black wires over here that are linked up to each other, right? So they are actually blue wires. They're linked up to each other, and there's one black wire that flows out, that goes all the way to the blue bar over here, to the ground, so that it comes out from the enable minus and it goes all the way to ground here. Also, we have these 4 wires over here, okay? These black, green, red, blue, that ranges from A minus to B minus on the stepper module. So these wires are going to connect to the motor, right? The wires are not too long. That's why I've actually got some extension wires to kind of elongate the extension. And these wires actually can be connected to a heatsink wire. So basically color coded it, so you just need to connect those wires with like the green heatsink for the green wire and the blue heatsink for the blue wire, and so on. Alright, so I have my setup over here all nice and ready. So I just want to go through the connections over here. So we have the motor, which is inside the turntable, and what flows out of the turntable are the 4 colored wires that I've described, and that kind of flows in. So there's a lot of extension cables coming out that I've connected and secured with a heat shrinks, and that kind of connects all the way through this hole into the control box here, and that goes into the the 4 pulse pins that I have over here, if you can see here, right? Second of all, I also have this power adapter, which is, you know, screwed in here. So that's the positive, which is the orange, and the ground, which is the negative over here. So that links to here, and that also feeds into this power barrel jack here, and that links out to a power supply adapter, an adjustable power supply adapter, which I can adjust it from 0 to 24 volts. I also want to talk about the connections for the motor. So if these things go loose, you know, if these are loose from each on this end, you know, it doesn't really matter because you know, you can just reconnect them back, right? Make sure all of these 4 are always in, you know, connected to these wires when you are always powering up the table, so that, you know, you don't want to have some sort of a short circuit. So you know, always make sure that these 4 are connected. But in the case when it comes out, you know, you just match the colored heat shrinks to the wires. So there's no need to think so much about that. But yeah, I'm probably going to tape this together, but in an instance when it's not working, you may want to check this connection and make sure this is connected. Also, if you notice, over here, there's a wire flowing out from the enable minus pin. So that's actually linked up by the negative pulse pin. So I connected it to a wire over here, and it flows into the negative direction pin, and then into the negative enable pin that flows out into a ground bar over here. And as you can see, that there's 2 power bars, 2 power strips here. So they're actually shared. So that's why I've connected the minus to the minus and the plus to a plus. And power kind of flows like this in a horizontal direction. And for the breadboards, the current kind of flows in the vertical direction. Also, you can see over here, I have 2 wires. The red one goes into V-in over here, and the black one goes into ground. So these things may come off, so you want to make sure that these are secured. And this is kind of hooked up to a, you know, how do you describe this? This kind of connects to the 9-volt battery, so you can be able to power up the microprocessor. So you have 2 things that's going to be powered up. The microprocessor, which needs the 9-volt battery, right? And the barrel jack, which needs to be connected to a main switch. Okay, I also have a DIP switch over here. So basically, this is to switch between the modes of the turntable. So actually, this thing might fall off sometimes, so you can actually just take it out and put it back in. Make sure that the ends are aligned with the wires, you know. So you can just take it out and put it back in anytime, but yeah, it's pretty easy to fix. No worries if it falls off. But basically, there are 5 modes for this stepper module. So this is kind of like a switch where if you have all of this off, it's going to be a default mode of turning a bit each time you press. But let's say if you want it to be a higher power, since you have a heavier load. So let's say we have something like a something like a heavy tool that's around 500 grams or 1.2 pounds. So if you put this here, you probably need more power to turn it on. So I'll probably turn it on either to 1 or 2. So I'll have 1 turn on, right? So this is gonna output more power. And if you are having even more heavier loads, you can even go to 2, right? So that's gonna turn a bit more. But if you're gonna have heavier loads, even heavier loads, then that is basically gonna turn less, right? For free is gonna turn even more, right? And for 4, you're gonna be basically making half a rotation for the turntable. So if you press it 1 time, so you have number 4 on, it's gonna turn half. It's basically gonna turn half, clockwise and anti-clockwise, right? So if you're gonna just go back to default mode, just make sure all of it is off. So each time you're gonna switch between modes, you make sure that only 1 pin is on. So basically this is state 1. And if you have 2 states on at the same time, then you don't really know which state you're in. So make sure that when you're switching between states, so state 1 you only have switch 1 on, state 2 you only have switch 2 on, and so forth. And if you want to go back to default, which is state 0, then you just keep everything off. Alright, so in an instance where the loads are really heavy or they are unevenly distributed, so over here you can see that I have a basket and a toolbox. This is almost 2 kilograms, and you know one side is more heavier than the other side, so it's uneven distribution of weight. So that probably requires more power. I probably would go to modes like 3 or 2, just to switch between the movements a bit, right? Because you probably need higher power for that. There might be a case where due to friction itself, it takes a lot of torque to move this table, so it might judder a bit, and sometimes you won't really see it moving really smoothly, or it might be like sagging. It might be going back and forth a bit. This is not an electrical issue, it's more of like a frictional issue. So every time when you come across this issue, I would encourage you to go to mode 4, right, and to press the button. So you're going to make one full rotation, so that's going to overcome any frictional force, and hopefully you know, you just make two turns, then it should be 360 degrees turn, so you'll be back to normal, and you can go back to the mode that you want. So I can go back to mode 3, and I can keep on continuing what I'm doing, right?